How do you know it's frozen? How do you know it's not plastic or cement?
Because it's liquid.
Well, cement's hard.
You see the water.
You see water on top? Okay. That's true. Okay. So good observations. And how can we find out if this is ice? We know it's hard, so we do one test. So when I test that, make sure it's hard. You give it a little knock. Hard or soft? Okay, how else can we determine just by touching or looking at it if it's ice? Is it cold? Okay, who wants to test if it's cold? Let's test if it's cold. Okay, so how do you plan to test that? Finger on top of it, okay. Test?
I hope it's contagious.
Right, so what if it was contagious? How should we test if it was cold or not?
A thermometer.
A thermometer. Oddly enough, I have one right here. So who wants to test the thermometer? Want to test the thermometer? So here's the thermometer. Oh, how do you want to test that? Okay. Might take a couple minutes, so I'll keep talking. Hey, let me know what the temperature is in about a minute or two. The trick with that is because it's frozen solid, it's hard to stick the thermometer in it. So we'll talk about that in a second. So what I have up here are models of permafrost. So which one? So oddly enough, that one looks kind of like this. We have a lot of permafrost, a little bit of active layers, the water up on top, it's a little bit of active. And this one has very little permafrost. So which one, A or B, is good for berries? A? Or B? A, okay. Which one's good for building a brand new house? A or B, okay. All right, we'll find out. So what I need you folks to do, I'm going to pour out some of that active layer, is come on up, grab a permafrost core, and what you'll do, very carefully, is pour some soil on top of your permafrost core. Now, is this going to be active layer or permafrost?
Active.
How come? Well, why is it an active layer? Is it frozen? Well, how do you know? Okay, test it, see if it's soft. You can give it a little dot. Okay, soft or hard?
Soft.
Okay, and what's the temperature? Do the finger test or do you want a thermometer test? Okay, it might be contagious. You never know. So I'll leave this on your desk for a second. Just insert the temperature probe. So Amy, what's the temperature on the...
Also 60.
Yeah, you know why? Because the actual thermometer piece is like in the middle there, so it's really hard to tell what the temperature is. So I should have frozen it in there in place, but I didn't do that in time. It's kind of hard to do now. Try to push it through. Just try to break the plastic. So what's the temperature of the soil?
65.
65? And what's the temperature of the air? Temperature of the air?
It is 70.
Okay. So it's not quite the same temperature as the air, but it's definitely not frozen. Good to know. So I'll need the groups to come on up and choose a permafrost core and add some soil to it. Try not to spill. Add the soil up here so this plastic cover keeps it nice and clean. Yeah, add it up here. Add a couple inches of soil. Let's go down. Oh, it's going down now. It's down to 50. Yep. Awesome. Yes. So maybe you know where it is? Okay. Let's see if we found someone to help you out.
Are we don't need more?
You just need one.
Yeah.
Yep, so, so tell me when to stop pouring.
Check. Stop.
Stop, okay.
It's not frozen all the way through. It's like
Oh, yeah.
It's an ice storage.
Yeah, so if you drill a hole through there, what can you do with that space?
It's
Can't do
a
anything with
food storage.
Well, there's water in there though, right?
Yes, we can't
Yeah.
do anything.
You could drain it out.
So bring your ice core.
It smells like sand.
Yeah, you can pump the water out. We can talk about groundwater and how we can access that too if we want to. So pour some soil on top.
We can have
Yeah,
this,
Come on up, folks.
do you want us to take it out?
You can leave it in if you want to. You'll have to take it eventually, but
So we just put this.
Yeah, pour some soil in. I can run this, sorry. We're just there, I know. Oh, look.
How much soil?
So which ice core do you want? You have to make a choice.
Okay.
I'll let you decide.
It's a couple inches.
Well, how do we know what a couple inches is?
Down.
How do we find out?
Which one?
Rulers, look at this. Do you want blue or green?
This is the
That's purple anyway, so you get green. Take a ruler. Add a bit of soil. Looks good, alright. Get it back to your desk. Make sure you don't drop it, because it's maybe
It
it'll be
went
soil.
down 40 degrees.
40 degrees so far?
Yeah.
Okay. How far should it go down to?
I don't know.
Is that Fahrenheit or Celsius?
Frozen is, frozen stuff is under 30 degrees.
Under 32 degrees Fahrenheit, yeah, I'll put that on the board. And that would be 0 degrees Celsius.
But since there's the active layer, it might be a little more.
It might be a little more, you're right.
Active layers can be colder. Really? They're harder. Colder. And also.
So you have your soil core, all right, let's add some soil to it. Add one to yours,
That's cool.
because you don't have a lot of permafrost. Look at that. Okay, grab a ruler.
No.
And you have, we only have 2 thermometers, we'll have to share this. No, there's a third one, good job. Let's take it back to your desk. Okay. So we talked about the active layer, we talked about the permafrost, but we still haven't quite made the connection between why the berries do well in permafrost.
Because there's like, it kind of stores it or something.
There's something that stored, what's stored up there?
It keeps like water in there.
Oh, it keeps like water in there, okay.
So like the land won't get like all dry.
Oh, so land won't get so dry, okay. So the active layer can get wet, right? Because it's thaws and freezes.
Under 40.
Can water go into the permafrost? I don't know. How can we find out? If you have permafrost, if you have an active layer, how can we do an experiment to see if water goes into the permafrost?
Put water.
Put water in it. Hey, look at that. So we have this very complex chemical, dihydrogen oxide. So you have to be very careful with dihydrogen oxide. It can be deadly if you inhale it.
Oh, I worked with that before.
Dihydrogen oxide?
Yeah.
I hope so.
Except we used those little tweezer things, the eye drop things.
Oh, okay. This might be a little bit different though. So dihydrogen oxide. I'll write the equation on the board for you. You might recognize it. Dihydrogen, 2 hydrogens and an oxygen.
H2O.
Who recognizes that equation? I
H2O.
think you do. H2O? Yep, this is water. So dihydrogen oxide is just another name for water. And how is water dangerous if you inhale it? Go in your lungs, you get drowned. Yeah. So you have to be careful with that. So I'll come by and pour you 50 milliliters of dihydrogen oxide, and then you can pour it into your soil core, and I'm going to measure to see how far down the water goes. See if the water actually goes into the permafrost. Okay, you get 55 milliliters. So before you pour it in there, on your paper, you can.
It's already sinking.
It's already thinking?
No, sinking.
Sinking, okay.
See on the side where the...
Oh, see, that might be a little bit of a challenge for the experiment because we have basically a well that you guys dug into the ground. Let's see what happens. Don't pour it in yet quite yet. Don't pour it in quite yet. Before you pour it in, I want you to write on your paper on the second page what you expect to see happen. this is the hypothesis. So actually, this is a prediction. You have an experiment, you have observation you've already made, and now you're going to see what you think is going to happen, which is a prediction.